Southern California Edison has been providing electricity to Southern and Central California for more than 125 years. In order to safely deliver reliable electrical service to our customers, we rely on electrical infrastructure, such as towers, poles, wires, and transformers across 50,000 square miles of service territory. Your safety and the safety of the public is our top priority at SCE. Incidents impacting our electrical infrastructure do occur, such as windstorms, wildland fires, or vehicles hitting poles. And being aware of the hazards present in emergencies where utility lines are involved is critical for first responders. During emergencies, we come together as trained professionals. Emergency responders are typically the first on the scene and can provide us with valuable information. Our utility workers are trained to respond effectively to electrical emergencies to prevent harmful consequences to first responders and to the public. We each have a role in such emergencies, and reviewing and following electrical safety guidelines can help keep you safe. Understanding how SCE's electrical infrastructure operates and the flow of power through the system is critical to knowing how to respond safely during electrical emergencies. Electricity is generated at a power plant at about 20,000 volts, but leaves the power plant at an increased 220,000 or 500,000 volts for more efficient transmission. This high voltage electricity travels along transmission lines to areas where power is needed. As electricity nears commercial and residential centers, the voltage is decreased to either 115,000 or 66,000 volts at large substations. Closer to commercial and residential districts, the voltage is reduced again at smaller distribution substations to between 4,000 and 33,000 volts. Current then travels along distribution power lines to neighborhoods where the electric stream is transformed into usable voltage. Finally, electricity flows from the pole line in a service drop or from an underground transformer to serve the customer.
It takes one split second of a misstep to alter your life forever. No matter how good the quality of health care is, no matter how good the quality of burn care is, there's nothing that can replace prevention and attention. And it is not good to be burned.
I'm Captain Howard Orr with the Santa Barbara County Fire Department, and I've been on the department 21 years now. Just before 2 o'clock, the bells went off for a wildland or a brush fire. As we traveled through a corral that was adjacent to the house, I realized there were a wellhead and 2 old dead trees preventing us from getting to the trail. So I knew something had to move. The wellhead wasn't going to move, and I looked at the 2 old dead trees, and I realized the smaller one is what I was going to go and try and pick up and move. My engineer, Bruce Stapp, had counted the lines in between the 2 intact power poles, and 3 lines in, 3 lines out. What we didn't pick up on was there, past that pole was another set of wires down. I've never been on a call where there's been more than 1 set of wires down. There may be 2 adjacent wires next to each other, but never where you have wires down, pole to pole intact, and then farther down the line, there's additional lines down. So it had never even occurred to me to even consider that. So the first step I took, I stepped on the wire. I fell back and landed on the wire. As I landed on it, then I received a larger jolt, shocked at about what was estimated about 7,400 volts. I was on the wire for about 30 seconds. I remember every second of it. I remember every thought that went through my mind. My wife, Monique, we've been married about 5 years. And my son, Dylan, who had just turned 2 years old a week before. And my daughter, Taylor, who was 3 years old, just short of her 4th birthday. And I realized I'd never see them again. The current caused every muscle in my body to contract. And that was the most excruciating pain I've ever felt. My arms locked up into 90-degree turns, my legs came off the ground. The current traveled across my arm, down my right arm, out my hand, and arced to John about 2 feet away as he reached for me. John received the jolt and was knocked back. At that point, I remember the thought of, my body's telling me, my mind's telling me, roll off, but physically I can't move, I'm paralyzed. So John came in. At that point, he had turned around after getting knocked down the second time, saw our other 2 firefighters from the airship coming over, one of them having a bundle of hand tools, wood shovel tools. John grabbed one of those shovels and started to reach out for me. John took that shovel and he laid it in the crook of my arm. As it was bent, he laid the head of the shovel in my arm and used it like a gaff to pull me off. I remember when they took the shirt off and they're looking at my back, nobody was saying anything. And I realized that must be the bad one. They flew me initially to a local hospital, Marion Medical Center, and to the emergency room where they did an initial assessment. After that, made plans for sending me down to the burn unit in Sherman Oaks at the time. It was Grossman Burn Center.
I'm Dr. Peter Grossman. I'm the director of the Grossman Burn Center at West Hills Hospital here in West Hills, California. One of the things that a first responder has to be aware of is what is the risk of injury to them. When we're talking about a hot wire or a hot line that is still going, even pulling the patient away from the source of injury puts them at risk. And so one has to really be aware of their circumstances, because it is incredibly dangerous out there for first responders when they're in the field seeing somebody who is down because of electrical injury. Oftentimes it's a simple mistake, and oftentimes it's not just a rookie out there, it's a veteran who just has done this so many times over and over again, and they just made one simple mistake. Usually the entrance is going to come through an upper extremity, a hand, and then depending on what they're leaning against or what's holding them up, they'll get some type of exit injury. And then, of course, it's everything that's in between may or may not be damaged. We tend to see much more deeper tissue damage, much more significant damage to the underlying nervous system. So unfortunately, oftentimes we're left with having to remove a great deal more tissue than we would with a standard burn. Sometimes that results in amputation. So it's very important to understand that, well, as a first responder, your instinct is to get the patient away from danger. You also have to always remember, as you've been trained, that it doesn't do any good if you end up being one of the victims as well.
We look at burns of an electrical nature, much as you look at a high-velocity bullet. The entrance is small, the exit is huge. But as soon as it touches the skin, it's looking for a way to get out of the body. Quickest way is to go the least resistance. That's high school physics. And in our body, most least resistant way is through the nerve endings. So it's going through the digital nerve, picks up the median, the radial, or ulnar nerve, heads back up to the brachial plexus, heads back up to the spinal column. It's trying to get out. So it's going to go north, and it's going to find, okay, there's no place to go up here in the brain. Let's get out of here. It finds its way out. It grounds itself. That's the explosion that comes out. But as it's going through this body, the heat that's transmitted by that nerve ending is damaging everything inside. The sheath around the nerve, the muscles, sometimes the bone. And that's why an electric injury is really one of the toughest things we deal with.
So what my recommendation is when it comes to burn gel is that it should be used prudently. Look at the entire circumstance. Look at the entire situation. For burns that are less than 15 or 20% body surface area, I think that it has benefit. It gives comfort to the patient, and it decreases the progression of swelling. Once it's on, my recommendation is to leave it on until the patient gets to the emergency department. Then the emergency room physicians can remove it and evaluate the wound more.
Throughout the electrical system, electricity is insulated and isolated from the ground. The most common of these insulators is the physical distance from the ground to the power lines atop our poles and towers. It's a common misconception that these power lines are further insulated with sheathing, but most are not, which is why coming into direct contact with these bare wires poses the greatest threat to you, the first responder, and to the public. Contact with low voltage wires happens much more frequently than with high voltage wires and may cause your muscles to involuntarily contract, which could paralyze your heart. But contact with either high or low voltage can be fatal. When you encounter downed wires, including communication lines, be extra cautious. Always assume the line is energized until it is identified and proven de-energized by our qualified electrical workers. It is impossible to determine if a wire is energized by its appearance. While some wires will jump, whip around, curl up, and make loud sounds, or emit showers of sparks, others will lie there silent. Don't be misled. The wire and ground around it could be energized and should be avoided. Because of differences in ground potential, disconnected wires may be live but not arcing. Wires can be re-energized without notice due to automatic switching equipment, backfeed, circuit testing, or environmental conditions. If you are first on the scene of a downed or sagging wire incident, park away from overhead wires and stay in your vehicle until you have carefully examined the incident area.
53 Boy 5's 1097, where the wire's down at 8838 Main Street. Let me get one unit to block off Main and power to stop all vehicular and pedestrian traffic. 53 Boy 5. Also, can you advise Edison of the pole number? It's going to be 1890237 Edward.
Do not attempt to move any downed wires. On all downed wire incidents, notify us and set up a safety perimeter at least 30 feet away from the wire. Continue to provide a safety perimeter and deny entry until our qualified electrical workers arrive to eliminate the electrical hazard. It's important to visualize the flow of electricity from pole to ground. Be extra vigilant during inclement weather, as water conducts electricity. Don't touch or step in water near a downed wire, and do not attempt to extinguish a fire with water near a downed power line. Only our qualified electrical workers can determine if a wire is de-energized and safe to approach. At night, use a light to trace all conductors from pole to pole until you've determined the full extent of the damage and the location of all downed wires. Be extremely careful in dense vegetation areas where wires may be camouflaged or hidden, especially at night. And as you track the wire's path, locate all wire ends and stay clear. If you encounter a downed wire in one area, always assume that there's another downed wire location at the incident site. Always be on the alert for conductive materials that may be in contact with the fallen wire. This includes metal fences, guardrails, signposts, sheds, rain gutters, and other metal structures. A metal fence, for example, can conduct electricity anywhere along its length, which could be a considerable distance and out of sight from the wire. If a downed or sagging wire is touching a vehicle, fence, pool of water, or other conductive element, that element is as hazardous as the wire itself. Remember that even wood can be a conductor when wet or dirty. Touch potential occurs when a person creates a current path to ground by touching an energized object. Here's a rule you should never forget. Never touch wires, equipment, or objects because they may be energized. If you encounter a downed wire, these are the steps to remember. Assume all power lines are energized and potentially hazardous. Stay a safe distance away. From a safe distance, examine the area and locate all wire ends and stay clear. Set up a safety perimeter at least 30 feet around all electrical hazards. Water conducts electricity. Do not touch or step in water near a downed wire. Do not extinguish fires near downed wires. Do not attempt to touch or move downed wires. Notify us immediately.
I'm Luis Navarez. I'm a division chief with the City of Tulare Fire Department. Been with the department 25 years. We received a call of power lines down. We had a lady that lived next door to where the power lines were down. She called us over there. She showed us her tree that was, there were several limbs that were smoldering. So we're looking at the tree. It was in the winter time, so it was foggy. Couldn't see any power lines there. We thought maybe it was one of the one of the wires that swung down, because we did have wires lying across the street. So we looked up at the tree. We seen there was some smoldering on the tips of the limbs. High enough, the limbs were high enough where I can reach. We went back to the engine. We made sure we had our gloves on, suited up, walked back over there. We're still looking around, see if we see any wires. Don't see any wires there, so I reach up and break the limb. I reached up with my right hand, broke one of the limbs. Then I reached up with my left hand, and as I grabbed the limb, I also accidentally grabbed a high voltage power line that was camouflaged in the branches there. I didn't see that. Became stuck to the wire for approximately 12 seconds. At that time, I knew exactly what happened. I knew that I grabbed a high voltage power line. I could see a halo of electricity all around my body. I could hear the buzzing noise from the electricity, real hard shaking. I think I started trying to pull myself off of the wire. At that time, there was also one of our engineers, our fire engineers, that he seen what was going on, so he runs up and he was carrying this metal clipboard. He throws the metal clipboard, hits the wire, which I believe that helped me disconnect from the wire because I'm pulling myself away from the wire. And I think I tripped as I'm pulling backwards, as I'm trying to backpedal, and disconnected myself from the wire. I'm laying there on the ground. Firefighters run up and drag me away from the wire. They load me on the ambulance, take me to the local hospital. As I arrived at the emergency room in the Tulare Hospital, that's when I started feeling the burns and the pains on my legs, my back, and I started feeling some of the exit wounds. And they stripped me down, took my clothes off, and they were able to see I had approximately about 8 different exit wounds on my calves, on my butt, my back, my underarm, my hamstrings. I had several, exit wounds, which are third-degree burns. So I ended up at the burn unit in Fresno. At that time, I think I spent about 6 weeks in the burn unit and going through skin graft surgeries every Tuesday and Thursdays, skin grafts, and that led to the amputation of my left hand.
Vehicles hitting poles are a relatively common occurrence, especially during the holidays, and electrical hazards are not always evident. When you first arrive at the scene, notify us through your normal communication procedure with the exact address or closest cross streets.
Engine 286 in the corner of Power and Commercial. We have a vehicle under the pole, wires down, smoke showing.
This will enable us to expedite a response to the incident. Set up a safety perimeter at least 30 feet away from the area to restrict access and protect the public and avoid staging under overhead wires. If there are inclement weather conditions, remember not to touch or step in water near a downed wire, as water conducts electricity. It could be energized. Never attempt to move downed wires. If occupants are inside the vehicle with a wire down and the victims are uninjured and there's no imminent life safety hazard, the safest place for them is inside the vehicle until the wire has been de-energized. People are safe in the vehicle because their body is not creating a path to the ground for electricity. However, anyone who touches the vehicle or the power line may be injured or even killed. Notify us immediately. From a safe distance, instruct them to stay in the vehicle until our qualified electrical workers have declared the wire to be de-energized and safe to approach. If the victim is conscious and there is a vehicle fire or other immediate threat, fight the urge to approach the vehicle. You could move into an electrically charged area. From a distance, establish contact with the victim and ask him or her to remain calm, stay in the vehicle, and follow instructions.
Sir, don't move. We're gonna help you. There's a power line down on your car and you could get electrocuted. Don't move. I'm gonna help you get out of the car, okay? You understand, right? Okay, I'm gonna walk you through this. First thing I want you to do is open up your door all the way, but don't get out of your car. Now I want you to put both feet on your door ledge. Stand up. When I tell you to jump out, I want you to jump out of your car and land on both feet. Keep both feet on the ground. Do you understand? On the count of 3, you're gonna jump out. When you jump out, don't lean back on that car, okay? Don't touch the car when you jump out. Do you understand? Land on both feet. When you land on the ground, don't pick up your feet. Ready? 1, 2, 3, jump. Good, okay, don't move, don't move. Now you're gonna shuffle your feet towards me. Shuffle and come towards me right now. Don't lift your feet up. Shuffle towards me now. Good. Keep shuffling. Come towards me. Good. Good.
When electricity enters the ground, it radiates out in concentric circles, or rings, like the ripples in water when a pebble is dropped in it. Each ring has a different voltage, dropping off from the central source to the outer edges. If you step one foot on one ring or voltage and the other foot on another ring or voltage, you've created a gap between voltages that the electricity has to bridge. That gap between your steps is called step potential. By jumping from the vehicle with both feet together and shuffling away, your feet cannot form a circuit for electricity to travel, so you eliminate the possibility of step potential. Eliminate the gap, and you eliminate the need for electricity to travel through your body. Walk in a shuffling motion at least 30 feet away from the source of electricity. If the victim is unconscious with a vehicle fire or other imminent threat, the victim must not be removed from the vehicle until the wire is de-energized and cleared away by our qualified electrical workers. If you follow your natural impulse and attempt to remove the wire, you could easily become another victim. We strongly discourage moving wires under any circumstances. However, exceptional situations may arise in which your first response team feels that action is imperative. In that case, your department policy should instruct you on how to act. Only you can determine the urgency of the situation. Steps to remember when responding to vehicles hitting poles. At a safe distance, examine the area and locate all wire ends and stay clear. Set up a safety perimeter at least 30 feet away from the incident. All power lines are energized and potentially hazardous. Stay a safe distance away. Water conducts electricity. Do not touch or step in water near a downed wire. Do not attempt to touch or move downed wires. Notify us immediately. If there are occupants in the vehicle, the safest place is inside the vehicle. If there is a fire, instruct them to jump away, staying clear from the vehicle and downed wires, and shuffle away at least 30 feet. Groundwater from hydrants contain minerals, which can conduct electricity. When a fire hydrant becomes severed, such as in a vehicle accident, it can eject water into the air and flood streets. The spewing water in contact with an overhead power line can now be a path to the ground for electricity and an extreme hazard. If this is a situation you encounter, isolate the area and deny entry, and notify us immediately to assess the electrical hazard. Although rare on our system, some streetlights have the potential to be high voltage. Treat any severed streetlight hazard as a downed wire or vehicle hit pole incident. Never touch wires, equipment, or objects that may be energized. Assume all power lines are energized and potentially hazardous. Stay a safe distance away. At a safe distance, examine the area and locate all wire ends and stay clear. Set up a safety perimeter at least 30 feet away from the incident. Water conducts electricity. Do not touch or step in water near a downed wire. Do not attempt to touch or move downed wires. See the path, don't be the path. When you arrive at the scene of a structure fire, locate the power sources and the electrical equipment you could come in contact with. Be careful not to stage equipment or personnel under the overhead wires. Communicate potential electrical hazards with your coworkers. Contact us according to your department's policy.
We're at 164 South Walnut. We have a single-story commercial tilt-up, smoke and fire showing. We also have wires down, possibly delaying our fire attack. Could you contact Edison? We have a life safety emergency, and get an ETA, please.
One of your first priorities is normally to disconnect the involved structure's utilities by opening the main circuit breaker on the electric service panel. If the main breaker won't open each individual circuit breaker one at a time. If the panel cannot be accessed, contact us with the nature of the emergency. Stay clear of metal gutters and other materials that may conduct electricity. Never use metallic ladders near any energized equipment. Even wooden ladders can conduct electricity if not completely clean and dry. Stay away from service drops and weatherheads. Be aware that some structures may have more than one service drop. Keep yourself and your equipment at least 10 feet away from service drops that run from utility poles to structures. These wires may appear insulated, but their coating is not designed to protect you from electric shock. We recommend that you never cut any electrical conductor. The risk of cutting wires includes arc flash and contact injuries, both of which can be fatal. Only a qualified electrical worker should cut an energized conductor. Notify us in this instance. Never pull an electric meter in an attempt to de-energize a structure. Meters are not switches. They are not designed to break electrical load and can catastrophically fail due to arc flash faults if removed improperly. When at the scene of a structure fire, remember the following. Locate all power sources and electrical equipment, including overhead power lines, weatherheads, and circuit breakers. Black covering on service drops is not insulation. Stay clear of metal gutters and other conductors of electricity. Do not stage personnel, equipment, or vehicles under overhead wires. Contact us immediately with the nature of the emergency and whether or not your personnel will remain on scene. Aerial operations are a high-hazard, high-risk operation. Take extreme caution when performing operations around high-voltage power lines. Electrical contact with an aerial ladder or device could have catastrophic consequences. When performing aerial operations, keep all personnel and equipment at least 10 feet away from overhead power lines. Remember, distance is your friend. Consider placement of fully extended aerial equipment and always use a spotter. No equipment operator working alone can safely judge the distance from the equipment to overhead power lines. If your aerial equipment comes into contact with a power line, it should be considered energized. Stay put, warn others to stay away, and have your dispatch notify us immediately. If you must get off equipment due to fire or other imminent danger, jump clear, land with your feet together, and shuffle away with small steps, and remember step potential. When it's safe to do so, have your vehicle equipment inspected. Notify a qualified mechanic, letting them know it was exposed to an energized power line. Most energy theft problems are associated with illegal grow houses. These grow houses tap into our service lines before the meter, which allows them to steal power without being detected. Tapping into the electric grid in this manner is extremely hazardous and does not provide circuit breaker protection to prevent injuries or fire ignitions. When encountered with a possible grow house, the hazard level increases exponentially. Once you've identified a grow house, stop and notify us immediately. The only way to clear illegal wiring safely is by having our troublemen, who are qualified electrical workers, clear the electrical hazards. Only then may fire suppression operations continue. Properly installed solar systems are designed to automatically disconnect through a transfer switch if our system is offline. When the transfer switch is open, separating the solar system from SCE, it prevents the possibility of backfeed on our system. Backfeed is a hazard to our employees and also first responders on the scene of an emergency. A properly installed solar system looks similar to this: solar panels, solar electrical panel, and transfer switch. Solar panels constantly produce electricity when exposed to a light source and should always be considered an electrical hazard. Always treat panels and conductors as energized equipment. The only way to stop the solar system from producing energy is to cover the panels with 100% light-blocking material, such as certain types of tarp or plastic. Wildland fires occur in many parts of our service territory. The most important thing to remember is to maintain a safe distance from overhead wires, at least 1.5 times the height of the power line structure, and restrict public access outside that safe approach area. Do not identify cleared areas around our towers or poles as safety zones, temporary refuge areas, or escape routes. Look out for overhead wires in and around the fire area. During suppression operations, personnel involved in fire line construction or extending hose lines need to be aware of hazards working near or under overhead wires. Smoke contaminants, fire retardant, foam, gel, or water can conduct electricity directly to ground across insulators through the pole or tower. Direct flame impingement on wires can cause a power line to arc directly to ground, similar to a lightning strike and just as dangerous. Remember to treat all downed wires as if they're energized. Downed wires can energize cable lines, equipment, fences, phone lines, and any other conductive material. Communicate with your personnel. Tell them the location of all power lines that are or could be involved in the incident. Communicate with us to report any damage or potential damage to power lines and give an exact location for our crews who will respond. Inform us of any firing operations or aerial drops that are planned around overhead wires. We will provide a representative to assist in mitigating power line hazards. Avoid identifying escape routes that would take personnel under or near power lines. Choose a safe escape route away from overhead wires. Safety zones and temporary refuge areas must not be located under or near power lines. Fire shelter material is conductive and may attract an arc if a power line faults to ground. The same rule applies to the incident command post. Do not locate the incident command post or park equipment under power lines. Aircraft should avoid all wires in and around the incident. Pilots should never fly lower than the power line tower or structure. Aircraft should stay away from power lines when making drops on fires. Aerial drops of fire retardant, foam, gel, or water can damage insulators and create a conductive path to ground through a pole or tower. These agents can also provide a conductive path between wires, causing a fault or arc that may cause damage and lead to wire down hazards. Extinguish pole fires below high voltage conductors and equipment in wildland fire areas as soon as they are discovered. Burning or smoldering poles left behind in a burn area may eventually end up as wire down hazards for first responders. These downed wires and poles can also block escape routes without warning. All personnel should take special precautions to avoid downed wires during and after a wildland fire. For your safety, remember to do the following before extinguishing a wildland fire. Maintain a safe distance from overhead wires, poles, and towers, including aircraft. Do not identify cleared areas around our poles or towers as safety zones, temporary refuge areas, or escape routes. And extinguish pole fires below high voltage conductors and equipment immediately. They could become downed wires. Notify us immediately. We can help mitigate power line hazards. Your first task on a pole fire is to identify the problem, because your plan of action depends on what is on fire and where the fire is on the pole. Most fires at the top of the pole are pole top equipment fires involving a transformer, capacitor, insulator, switch, automatic switch, or other apparatus attached to the pole. Consider these energized electrical fires as Class C. Do not spray foam, gel, or water on any pole top equipment or fires at the top of the pole. Notify us and wait for our qualified utility workers to arrive. Fires at the base of a pole are generally common Class A fires that should be extinguished. If it is evident that the fire at the base of a pole was caused by ground fire, you can put it out. However, if there are any doubts that ground fire is not the cause, be aware that the problem could be caused by underground electrical conditions or a downed wire. When in doubt, stay away and contact us immediately to de-energize the location before doing anything more. Set up a safety perimeter at least 30 feet away from the pole and continue to secure the scene. In cases where fire has created the possibility of a pole falling on a structure, consult your departmental policy on how to act. If the policy is to extinguish the fire, use a fog pattern to suppress the fire. Incidents in substations do occur, such as fires or copper theft, that may cause our equipment to not work properly and pose potential hazards. In all substation incidents, first responders should never enter energized substations unless accompanied by one of our qualified electrical workers. Our trained employees must always accompany you as you move about the substation and can safely identify specific equipment and voltages that are present. Only our qualified electrical workers have the ability and knowledge to de-energize sections of a substation or the entire station if needed. There are more than 1,000 substations in our service territory, using many unique construction designs. This makes it difficult to know what you might encounter at any location. If our qualified utility representative is not on site when you arrive in an emergency, immediately notify us, but do not enter the substation. Some substations are privately owned, especially at large commercial establishments. If you encounter a fire at a privately owned substation, assume all equipment is energized and potentially hazardous. Do not attempt to fight a substation fire from outside the fence. Protect any surrounding exposures and stand by until our qualified utility workers arrive. In our service territory, substations are energized facilities that are either attended or unattended. Unattended substations are monitored from a remote location where we may or may not be aware of the trouble. Some unattended substations may have phones at the gate, but the phones won't be active. In this case, use your normal communication procedures to notify us and request an escort into the substation. At attended substations, the main gate will be equipped with an operable phone or keypad with speaker for making contact with personnel inside. Use the device to call inside and then wait at the gate for our qualified utility worker to safely escort your resources through the energized facility. Prior to any firefighting or rescue operations at a substation, consult our on-scene qualified utility workers to determine safe parking areas for equipment, the energized status of all equipment on site, personal protective equipment requirements, and whether or not firefighting equipment exists in the substation. Be aware, once de-energized, mineral oil is a primary fuel involved in substation equipment fires. Cable trenches contain energized cables and can carry the burning oil to adjacent equipment. Provide early exposure protection to adjacent de-energized equipment and structures. Class B foam is the preferred extinguishing agent for substation equipment fires. Firefighting operations should only involve Class A or B combustibles after equipment has been de-energized. Rescue operations should only be conducted on or near equipment that has been de-energized and made safe by us. The incident commander should stay in close communication with our on-scene representative throughout the duration of the incident. The hazards you could encounter in a substation include high voltage lines, both overhead and underground, open high voltage buswork crisscrossing the station at relatively low height. Never drive beneath overhead structures without specific approval. Oil-filled switchgear, transformers, regulators, and capacitors. Note that transformers are typically located close to each other. The collapse of steel framework and aluminum buswork that's been damaged by intense heat. Explosions from oil-filled equipment, both overhead and at ground level. Falling wires both inside and outside the substation, and covered cable trenches throughout the substation. They resemble walkways, but they are not. Do not walk on any cable trenches. In all substation incidents, remember to notify us and wait for a qualified utility worker escort. Assume all equipment at substations is energized and potentially hazardous. Stage vehicles away from overhead power lines and other infrastructure. Emergencies involving underground manholes or vaults are high-risk situations for first responders, even if the appearance above ground looks normal. If flammable gases are present in the manhole, removing the cover could provide enough oxygen or sparking to cause an explosion. If gases are present in the cable ducts that run from manhole to manhole, there could be additional explosions in adjacent manholes. If an underground transformer in the vault has failed and the oil is above the ignition temperature, it could explode without notice. In the underground environment, one failure in the system has the capacity to cause additional equipment or cable failures. The resulting explosions could seriously harm you and others nearby.
I need you at code 3 here. We need all your mobile shut down. We have a firefighter down.
Here's what to do. Notify us. Give the location, number of manholes involved, and the nature of the emergency, such as flames, smoke, or the smell of gas. Establish a safety perimeter. Keep the public away and route traffic around the area. Don't park vehicles near vaults, manhole covers, or vents. If the cover is in place and smoke is coming from the holes in the cover, do not attempt to remove it until the conditions have been thoroughly discussed with our qualified utility workers. Never spray foam or water into an underground structure, even if a fire is visible, unless the structure has been de-energized.
God.
Blowing the out of my bucket.
There's f***ing weld in it.
Dude, I gotta get the bucket off it.
You can't.
I have to.
You can't.
I have to.
Dude, you're crazy. Try.
I in my bucket all up.
You want to risk going in there and not being isolated, man? You're crazy. It's a bucket. It's 13,000 volts.
I am.
Construction digging equipment may come in contact with underground power cables. Equipment in contact with underground cables or other electrical infrastructure may be energized. Do not approach or touch equipment, people, or objects that may be in contact with energized electrical infrastructure or facilities, such as an underground cable or a pad mount transformer. It may still be energized. We care about your safety and the safety of those you serve. Our call centers, like yours, are available 24 hours a day, 7 days a week to respond to your needs. Our crews are on duty from 7 a.m. to 9 p.m. and on call from 9 p.m. to 7 a.m. In nighttime emergencies, they must be contacted and dispatched to a problem area. When your dispatchers call our number reserved for emergencies, the 911 call, as it's known, is highlighted in red for urgent handling as a top priority. Our dispatcher will need some specific information to expedite our response. Be prepared to answer, what is the location address? What is the problem? Who is the point of contact and are they standing by? The location address, instead of the equipment number, is the most important information since it allows us to zero in on the circuit involved in the incident. If we can verify the circuit, we can sometimes expedite our response. Power lines can pose hazards for emergency personnel, even when they're not a contributing factor in the incident. Understanding the potential hazards and dealing with them correctly is critical to keeping everyone safe. We each have a role in such emergencies. Your role? Provide for the safety of all first responders and the public. Notify us and describe the nature of the incident, such as wire down, smoking transformer, or vehicle hit pole, victim unconscious. If needed, instruct your dispatch to report that there is an electrical life safety hazard. Give a street address rather than cross streets if possible, and the pole or equipment number. Provide an on-scene name and contact number if available so that we can communicate with you while in transit. When requesting an ETA, indicate if your personnel will stand by or leave the scene, and communicate incident conditions such as traffic blockages, command post and staging locations, or other approach information. Our role: provide timely response to public agency requests. Isolate the electrical hazard. Verify that electrical hazards have been eliminated from the incident area. Contain potentially hazardous materials such as oil spills, and communicate with the incident commander or officer in charge. Working together, we can help keep the community safe around power lines during emergencies. In large-scale emergencies and other instances when resources of all responder agencies are stretched thin, we will try to dispatch a field service representative to your location and relieve your personnel to ensure public safety and stand by until our crews arrive. During wildland fires, our representatives are quickly on hand to provide advice and liaison activities where transmission or distribution lines are involved. Pre-incident planning is another way we work towards our common goals. First responders can schedule substation tours or in-person presentations with our qualified utility workers to deepen their understanding of electrical safety.
I think after my accident, our department has much more situational awareness of any time we respond to power lines down, any electrical emergency. I think they're much more aware of what's going on, of the seriousness, the hazard, the threat of being close to any power lines. I can see everyone's they're more cautious. We set a perimeter, we stand by and just let Southern California Edison do their job. Our job is pretty much just to isolate the area, deny any entry, and protect any exposures.
I think if there's one takeaway from the electrical training that we've had since then is just to maintain your situational awareness. Is look overhead, count the wires in, count the wires out, make sure they match, and then continue to count those lines as you progress down the fire line and anywhere in the area you're working, because additional lines may be going down or may have been gone down you weren't even aware of.
Be aware of electrical hazards when responding to any call. Look up and around to identify all power lines that may be involved. Your agency's dispatch should notify us by calling the confidential fire and police phone number with the nature of the emergency and provide a street address. Consider all downed wires and electrical equipment energized until proven de-energized by our qualified utility workers. Maintain a safety zone of at least 30 feet and wait for us to make the scene electrically safe. Don't underestimate the hazards of low voltage lines and equipment. Don't cut or move any wires. Use extreme caution when responding to incidents involving electricity, especially at night. Never touch wires, equipment, or objects because they may be energized.
Or whether you're new or you've been around the fire service for many years, I would always tell someone how serious a power line is. Doesn't matter who you are, what color you are, anything. Power lines out there to actually take your limbs away and kill you.
You know, you always wonder why me? And a couple years later, I gave a presentation to a service club, to a Lions Club, and there happened to be a Catholic priest in the audience. And I was giving my story and saying, you know, I've had many discussions with God and never asked why. And I said, someday I'll probably find out. I just realized it wasn't my time, and I apparently got more work to do. And he put it really in good perspective for me. He actually said that, he says, instead of asking the question, why you? He says, ask the question, why not you?
If you see somebody that's had an electrical injury, don't go in there and try to rescue them. Electricity is bad. You're going to get hurt. So make sure that there's no wire contact. Make sure there's somebody there helping you so you're not a victim as well.
You are the ones on the front lines that have dedicated yourselves to helping others in emergencies. It is important to the public, as well as to your families, that you take every precaution against becoming a victim of exposure to energized electrical equipment. Please share these important electrical safety messages with other first responders and encourage them to follow these electrical safety guidelines. Many thanks to all the first responders who helped put this program together, and thank you for partnering with us and making electrical safety a priority to keep our communities safe. For more information, visit on.sce.com/safety on the job.